PBN, Performance-Based Navigation. Today we are at video number 2, so if you are interested in this topic, follow me into the Pilot Lounge. Before starting, I shall remind you that there is a disclaimer to my videos. The disclaimer is linked now in the top left corner, so please make sure that you're familiar with what is said on that disclaimer. And now, before moving on, I shall also remind you the importance of the like and subscribe. Unfortunately, ladies and gentlemen, my channel has failed. I didn't get enough like and subscription as needed. But since the last video was published more or less 1.5 years ago, I found a lot of pilots that told me, yeah, you know, I watched your videos, I found it very useful. And you know what is interesting is that there's many pilots that actually watch the video but they don't give the like and subscribe. So the watching time is very important for you too, but your like and subscription as well it is. So it's you that decide, by watching the video of course, and by giving the like and subscription, is you that decide whether this channel is gonna have more videos or not. So thank you very much for taking the time to do this little action, like and subscribe. And let's move forward and let's talk about PBN.
Paolo's Pilot Lounge. Like and subscribe now.
Let's get back to us and to the PBN operation. And first of all, last video I received some comments. What did we talk about first of all? Well, we spoke about the requirement for the PBN, why the PBN was introduced. Then we spoke about the certification of the RNAV, the limitations of the RNAV, and how it gets improved using an augmentation system, and therefore the type of approach that we can fly with an augmentation system. Some of the comment I've received is that I'm making it much more complex than what it actually is, and in fact you're absolutely right. Yeah, the practical course of the PBN, actually I skip it on the first video, so we can talk about it now. How do you practically use the PBN? Well, first of all, you must be qualified. So either you had your TPL, frozen TPL or CPL license in the last 2 or 3 years, either you do it a PBN course to get integrated the knowledge required for the PBN. If you don't have PBN, you can't operate in Europe in IFR. The PBN course is basically a computer-based training, and after that you get 2-hour simulator, more or less 3-hour simulator actually, plus a check, because 1 hour is a check. And in that training you actually fly a number of PBN approaches. You normally get a failure of a GPS, and therefore you do a conventional miss approach. And that's it. After that you are qualified, fully qualified for the PBN operation, meaning that once again you can use whatever type of navigation system, even if the navigation system you use has nothing to do with the aircraft you're actually flying every day. But that's it. With that you get fully certified for the PBN operation. How you practically use your PBN? Well, it's not that complex, as you probably know. You just have to load in the FMS the procedure, if you have an FMS. Otherwise, if you have a GPS, you load in the GPS the procedure, and once the procedure has been loaded in the GPS, basically you press the LNAV button or you press the GPS button, depending on the type of navigation, and your aircraft lateral navigation, your autopilot, will follow the route as depicted by the area navigation system. Congratulations, we reached the end of the practical course. So yes, it's absolutely true, the practical part is extremely easy. That's it, we're finished. Now, I know you're going with the mouse on the time and you say, okay, that's video number 2, there's a third video, and you know, it's like 1 hour long, so what we're saying for the rest of the time, but that's it. There's nothing, absolutely nothing to say from the practical point of view. the usage we do every day of the PBN, it's extremely simple. It doesn't even require a pilot. The system has been studied to make automated fly, so a computer could fly along without the help of a pilot. But as a matter of fact, the system, as we've seen, we could say likely for pilot or unlikely. It depends from the point of view, but as a matter of fact, the system in the certification has a number of chances of failure, and as a matter of fact, the systems are failing. So the pilots are needed just to cover for these failures, and that's why the knowledge is required about PBN in order to allow the pilot to understand what is he doing. What are you doing when you press RNAV? Are you flying a VOR conventional procedure in RNAV? Are you flying an RNP procedure in RNAV, or are you flying an RNAV procedure in RNAV? There are differences, there are differences among the RNP approaches. There are differences about flying an RNAV with an RNAV certified system and RNAV with an RNP certified system. So the pilot has to be aware of what is he doing, and that's why we're discussing all this theoretical stuff. But yes, I totally agree that in practical terms, the usage of the aero navigation system is extremely simple. Yeah, just push the button and the aircraft flies. Good. Well, let's continue. Now, yes, we defined how the system is certified, what is it doing. But now we have to define a bit better what the system is and what are the errors of the system. We can say that we're looking a bit more in detail of the error. I'm talking of the TSE, the total system error. So the total system error is defined as the sum of three elements. It is the navigation system error, NSE, the PDE, path definition error, and the FTE, flight technical error. Now, this very theoretical thing, it's really theoretical, and there's no real practical meaning, isn't it? No, there is a practical meaning. It's very important, this practical meaning. Those errors are totally different among them. Okay, the less important. Sometimes pilot they take it as an offense for them. The flight technical error is like the inability of the pilot to fly the predetermined track. Well, it's not the pilot is not able to fly the aircraft and can't keep the aircraft on track, but for some reason the aircraft is not on the predetermined track. Okay, this could be an autopilot malfunction. This could be pilot being unable to fly, or this could be simply that you are loaded your system with a speed which is excessively high, and or actually a speed which is excessively slow, and you show up at that point with a speed which is excessively high. And now the radius of turn on your aircraft cannot cover that small radius of turn that has been calculated by the FMS, for example. So the flight technical error might be connected to a number of things. It could be that you simply decided to go heading because you're vectored, or because you are avoiding some weather. So the reason of the flight technical error might be multiple, might be a pure mistake of the pilot, or might be a desired thing of the pilot intentionally deviating from the route for some reason. But why the flight technical error is the thing that worries me the less? Because the flight technical error, by definition, is something which is always seen by the pilot. You can see the flight technical error in front of you on your navigation display. Just look at the navigation display, just look at your HSI, and you will see that the aircraft is not on the magenta line. The HSI is not centered. If you're on an Airbus, your aircraft is not on the green line. That is the flight technical error. Your aircraft not being on the design path. Now, the maximum flight technical error which is allowable is half of the RNP, because the remaining half of the RNP is, let's say, dedicated to the technical system itself and not to the human error of flying the aircraft. But that's perfectly logical, because if you think about a VOR, what we do on a VOR is that we allow a maximum of 5 degrees deviation, which is half scale of the HSI. And if we allow half of the RNP, we're actually allowing half scale of the HSI. So what we're doing with the flight technical error is totally reasonable. Because of this flight technical error maximum allowable being maximum 0.5, I want to take advantage straight away is that because of this reason, it is prohibited to fly direct to the final approach fix on an RNP approach. The reason for this prohibited, it's because when you reach this point, the final approach fix, the aircraft will be turning, and then you will find yourself on the final, and on the final with an RNP of 0.3 and the maximum deviation of half of the RNP, you could, with the turn, find yourself outside the maximum certified area. So for this reason, they want the flight to be aligned with the final segment before passing the final approach fix, and that's why on an RNP approach you cannot take a direct to the final approach fix. But once again, I clear and clarify that is a formal problem, because once the aircraft is out of the magenta line, the pilot is aware of the problem. So if I doing an approach and I see that on my navigation display the runway is depicted on the left, or on my HSI the CDI is on the left, telling me that the final approach course is 3 miles on the left, now no matter the certification number, it's evident that this makes me aware that I am 3 nautical miles right of the center line, and if there is an obstacle in that position, I will think about it reasonably. So the flight technical error is a minimum problem, because once the pilot is aware of the deviation from the desired path, the pilot will take the appropriate correction. Now, for the other errors, we got navigation system error. Well, the navigation system error is what it really makes me concerned, is the error of the system in positioning your aircraft. The problem is that the system is not really positioning incorrectly your aircraft, because when you look at your instrument, your aircraft is always depicted in the middle of the instrument. So it's not that the system will start depicting the aircraft left or right, or in your HSI the aircraft start drifting away, okay? Now, what happens is that your aircraft is always depicted in the center, but the desired route is not where it should be. So the system tells me the desired route maybe is half of a mile to the right, and in reality the desired route is somewhere else. The system tells me that I am spot on the desired route, and in reality I am far away, like maybe 1 mile far away from the desired route. Now, if this error, this navigation system error, falls within the required navigation performance, I will not be advised. So basically it is normal that there is a navigation system error. It is normal that the system tells me you are perfectly on the navigation route, and then in reality I am somewhere else. But this normal must fall within a given amount of distance, and this given amount of distance has to be less than the required navigation performance. As we said in the previous video, there is still a remaining chance that your position is actually farther out, you are outside the required navigation performance, and the system will not advise you. There is also, of course, a statistical possibility of having your aircraft not being on the required route and the system advising you, of course. That is a bit more likely, I would say, but this doesn't cause a major problem, because then the pilot is advised and once again it will take a corrective action. To better understand the navigation system error, let's take into analysis this example where a pilot is requested to intercept course 285 from Dublin. The course is set and Warlock is armed, the aircraft is intercepting with Warlock. At this stage, of course, the pilot monitoring is set in the FMS, the direct to Dublin course 285. For this reason, the pilot flying will switch to the RNAV. We must note that there is a significant difference between the two navigation modes. The first mode, the Warlock, was actually tracking the VOR signal and the course 285. This signal is less accurate, but the integrity is higher. The second mode, the RNAV mode, corresponds to navigate from the GPS. So you are flying the course 285 from a GPS point, which should correspond to Dublin VOR. The error of positioning of Dublin VOR, so the GPS point named Dublin VOR, the error positioning of this point is within the RNP performance. At some point, we see that there is an error introduced in the navigation system. The position of the magenta line suddenly shifts, but the shifting of this magenta line is within the required navigation performance. Therefore, the system does not communicate to us any error signal. In fact, the aircraft is remaining positioning within an error of 1 nautical mile, which is the required error in navigation during an SAD. Therefore, the pilot is now flying away from the radial 285 from WMVOR, but this error remains within 1 nautical mile and therefore there is no information to the pilot. Once again, shall this error increase beyond 1 nautical mile, the pilot will get informed. Shall the required navigation performance increase, for example, to an oceanic requirement of 2 nautical miles, the pilot will then get informed if the error in positioning will increase beyond 2 nautical miles. So for the navigation system error, as I say, this is what makes me really concerned, but this concern is related to something that, statistically speaking, is nearly impossible. We're talking of 1 chance over 100,000, so it's a very rare event. The other problem that we have to talk about, and now here the problem might get more significant. Why might get more significant? Because the chances that the navigation system error exceed the required navigation performance and don't get advised are extremely minimal, but the fact that the navigation system error start exceeding way more than 2 times the navigation system error, so I start being somewhere completely wrong, my position is miles away from the reality, okay? Well, this is even more rare, practically speaking, is nearly impossible. Although we cannot certify it, yes, we can say it is nearly impossible. But let's talk about now another interesting error, which is the PDE, the path definition error. While the navigation system error is never seen by the pilot, and the flight technical error is always seen by the pilot, path definition error might or might not be seen by the pilot, and that's why it makes this error extremely interesting. Yeah, because it can only be seen at the planning stage. In fact, at the planning stage, it is a legal requirement, as written on the PBN manual, that the pilot verify the consistency of track and mile. Actually, the word used is reasonableness. So what does it mean, reasonable? Well, I don't really know. I don't have a number, you know. Is it 2 degrees error over 5 nautical miles something reasonable or not? Well, it's not defined what reasonable is, but as a matter of fact, the pilot has to check for reasonableness of track and mile on every single leg of the RNP or the RNAV procedure that he intends to fly. So the path definition error is an error that is, as the word says, caused by the incorrect definition of the path. But why should the path be incorrectly defined? Well, it is really possible that this happens because the authority will define the path on the ground that the aircraft should follow for a specific procedure. But then the ones that actually code this number inside the FMS is not the local authority, is not the aircraft manufacturer, but is the chart provider. So the chart provider, as it could be Jeppesen, as it could be Navtec, as it could be Lido, they will be coding the coordinates of the points, meaning that eventually one aircraft with one provider of database is flying a procedure perfectly, and the following aircraft, which has a different provider, we actually load a procedure with incorrectly coded points. And now this error could be subtle. Of course, if there is an incorrect coding, like a point coded north is actually coded south, you will see it because your SID maybe is 5,000 nautical miles long. So you will realize that there is something wrong. But it's not said that it's always evident. Sometimes the mistakes might be really minimal. I'm showing you in this video something that is quite interesting. You see that we're talking here actually of the ILS procedure in Fiumicino, around Fiumicino runway 16 left. There is an intermediate fix named Mixo, and normally the ATC will give you direct to this point to fly the ILS. Now, one day I found on the FMS that I inserted the intermediate fix, and as the ICAO says, the intermediate fix should make you align with the final. So I insert Mixo and I realized that yes, I am aligned with the final with that, but not perfectly aligned. There's still a little turn. So basically Mixo is not a good intermediate fix, and there was something wrong with that. By searching a bit more in detail, as you can see in this picture, it was found that there were two mixo points coded in the FMS, and of course by selecting one procedure or the other, the mixo point could be the correct one or the incorrect one. So one of those points were actually aligned with the runway, the other point with the same identical name was not aligned with the runway just by a few miles. So this is a subtle error of the system. And of course, eventually, if the engineer goes and checks mixo, the coordinate of the points will eventually even find that the coordinates are correct, because there is one point with correct coordinates in the system, but there's also one point with incorrect coordinate, and some of the procedure were actually using that point. So the error of path definition error is an error that cannot be quantified. Well, we can discuss what are the chances that my navigation start giving me a navigation system error, or what are the chances that the pilot start flying correctly the aircraft and find himself more than half of the RNP in the procedure. We can't really quantify what are the chances that when a point is miscoded, this point is more than the required navigation performance away from the desired real path. So the only protection we have for this is, as the PBN manual describes, is pilot checking at the moment of the briefing the reasonableness of tracker bytes of all points. So it is very important that once a procedure is selected from the FMS, and it's a legal requirement for all RNAV1 and all RNP operation, it is a legal requirement that the procedure is taken by the database of the system. So it's taken by the database of the GPS or the database of the FMS. And when this is done, it is important the very same way that the pilot cross-check the reasonableness of tracker miles, because as we just said, the mistake or the miscoding could be really subtle. It could be not really evident. Or in other cases, it's going to be really evident that the route is totally incorrect. Maybe there is a flyby that is become a flyover, or a flyover that became a flyby. These things might be evident. Path definition error is a significant error, and I would say is one of the most frequent one. Normally it turns out being a fine for noise deviation, stuff like that. But yes, it is a problem.
Paolo's Pilot Lounge. Like and subscribe now.
Good, we just spoke about the total system error, we spoke about the elements that could affect the total system error, and now I would like to have a quick chat about minimas for the approach. Yeah, because minima is another problem introduced with the PBN approaches. In fact, until yesterday, we only had approaches which had minima for non-precision approach or for precision approaches. So basically, ILS's microwave landing system were considered precision approaches, so at the decision altitude, and the VOR NDB approaches at the minimum descent altitude, because those approaches were considered non-precision approaches. Now the situation is made a bit more complex with the EASA coming and requiring all flights to produce a continuous descent final approach. So in Europe it is absolutely prohibited to do what is actually legal in many other countries, to do the so-called dive and drive, so to drop down to the minima, level off at the minima, maintain the minima, see if you can see the runway, and then land. This action is actually prohibited in Europe. You must do a continuous descent final approach, which means that you have to calculate a descent profile that allows you to be on the correct altitude every mile during the final approach descent, and once you reach the minima, either you see the runway and you continue on the same descent profile, either you go for the miss approach. This CDFA actually was already changing the applicability of the MDA, because if we are doing an approach, a non-precision approach like a VOR approach, for example, and we leave selected the minima, the autopilot will level off at the minima. So the problem does not exist, because we continue on the CDFA. Once we approach the minima, the autopilot acquires the altitude, the CDFA is interrupted, and at that point, even if we see the runway, we must go around. So the MDA remains the minima if your company or if you are operating in this way. But many operators have as SOP the fact of setting the miss approach altitude during the continued descent final approach. Setting the miss approach altitude is a protection, because in the event of a go around, that would say an unexpected go around, the aircraft will have the miss approach altitude already selected, and the chance of making a level bust are significantly reduced. But this introduces a second problem, and the second problem is that in this case, if the aircraft will continue the approach, well, it will reach the MDA and will continue through the MDA as if it would be an ILS. Now the problem is that the minima for the ILS already include the reaction time of the pilot to interrupt the approach and start the miss approach. Minimum descent altitude, so the minima for a VOR approach, does not include this safety margin, and this safety margin is not clearly stated by the authority. Well, there are some authorities that define a table which is 20 feet for category Alpha, 30 for Bravo, 40 for Charlie, and 50 for Delta. But as a matter of fact, the EASA did never publish any of those values. Therefore, it is solely at the discretion of the operator to determine what is the reaction time, or what is the altitude that corresponds to the reaction time of the pilot to initiate the miss approach. The thing is, the MDA in this case has to be revised. In fact, is what we call the revised MDA. Has to be revised and has to be increased to a higher value. This higher value is the value that includes the reaction time of the pilot. So the pilot, when starts the miss approach, will never get below the MDA, and this is because the MDA is never lower than the OCH. So if I descend 1 foot below the MDA, I could actually descend below the obstacle clearance height, the OCH. Therefore, there will be an add-on value, which is normally in Europe, there's two ways of thinking. It's 40 feet in one case, 50 feet in the other case. Normally the 50 feet is used by the company that also have wide body, so they make a uniform value for all the fleet. While the company that has only Charlie category Alpha will probably use 40 feet. But of course this depends from the company. So be aware that there are this possibility when you have an MDA, you might be in the need of adding some 40 or 50 feet to transform this MDA into a revised MDA, which actually corresponds to a decision altitude. Now this logic applies also for the RNP approaches. Now the RNP approach introduces a new type of 3D approach and a new type of 3D approach. So for 3D approach, of course, we talk about ILSs, we talk about microwave landing field system, and we talk about GLSs. But the other two new type of 3D approaches are the LNAV and the LPV. All these approaches, they are all defined with a decision altitude, because same as the ILS, it is expected that the aircraft stays on the vertical electronic guidance, and if it doesn't see the runway at the minima, from that angle of descent defined by the electronic system will interrupt the approach and go around. So it is included in the minima for an APV approach with vertical guidance. It is included in the minima the reaction time of the pilot. Now, if you have a non-precision approach, which is a PBN approach, as it could be an LP approach, localized performance, or an LNAV approach, LNAV only, well, in this case, you will have the minima published as an MDA. But because in Europe, you are required to make a CDFA, at this point, the NDA has to be revised into the revised MDA, adding these famous 40 or 50 feet. Bear in mind that if the intention is to level off, because there is the need of level off, like for example, it would be on a circling approach, well, in this case, of course, you never have to add 40 or 50 feet, because it is your intention to leave the altitude selected on the autopilot and to let the autopilot level off at the minima. So the adding of 40 or 50 is only required when your intention is to continue on the CDFA and land out of a CDFA. I hope this has been clear, because this topic makes a lot of confusion. It's actually, if you think about it, is actually something relatively simple, I would say. Another thing that we have to talk about is concerning the change in name. So sometimes it might even get a bit more confusing if you take an old chart, and there's still some picture of old chart hanging around, and sometimes you might even find an old chart which is still valid. But basically, since 2022, all the charts have been renamed. But I would like to attract your attention on this renaming process of the charts. Because this really demonstrates to you that when we actually had the PBN coming out, even those who certified the PBN had a little bit of confused idea. In fact, in the past, the RNP approach was named RNAV. So if you find a chart written RNAV GNSS, it means that that chart is an RNP approach. I mean, the idea is there. It's an RNAV system augmented by a GPS system, but yeah, a normal GPS is not okay to augment the RNAV system. Again, you have to use an SBAS, an SBAS, or GLS for the augmentation system. So yeah, that name is technically incorrect. So that's why they're changing it. So the proper name of an RNP approach, of course, is an RNP approach. And I carry saying that that is the proper name. What does it mean? That the ATC, when clearing you for the procedure, will clear you for the RNP approach. Because if you have to fly an LNAV approach, or if you have to fly an LVP approach, it's your business. It depends from the certification of your aircraft. The air traffic controller cannot know what is the certification of your aircraft. Even more, with the RNP approaches, we lifted the air traffic control from the responsibility of monitoring the ground station, or anyway, the required station for the approach. In fact, the tower controller or the approach controller, or anyway, the controllers, they have access to the monitoring systems of the navigation station. So the ground-based aids, they're monitored for the functioning, and in case of failure, there will be a warning in the control tower, for example, telling you we have a fault on the ILS, or we have a VOR became unserviceable. So there is a monitoring system that will advise the tower controller that a VOR, an ILS, or a ground station became unserviceable. But the tower controller cannot really directly monitor the GPS satellites or any other navigation system that you might use, like INS and IRSs, cannot monitor that to tell you that the RNP approach became unavailable. Let's take the example of a pilot flying an RNP approach. He has been cleared by the tower, and the tower controller at some point, for some reason, whatever, becomes aware of the fact that EGNOS satellite became unavailable. But this pilot is flying an LNAV VNAV approach. He doesn't even have a receiver for EGNOS. So the fact that EGNOS failed is totally irrelevant for this pilot. So if we would give to the tower controller the possibility to monitor, not only would be extremely complex, but it would make the thing even more complex, because eventually it will call a go-around for a pilot that doesn't even use that type of receiver. Therefore, today is the pilot for RNP approaches that is responsible to verify the serviceability of the navigation aids required for that approach. So, presence of satellites, range check, presence of the EGNOS, correct tuning of the EGNOS, and so on. These all fall under the responsibility of the pilot. There is one type of approach that we didn't talk about, and this type of approach is the RNP AR. That's a very specific type of approach, and that's why I kept it apart from the others, because it's really different. And yeah, the RNP AR has been changed, the name on the charts. The old charts, you will find it as
RNAV RNP. So if you find an RNAV RNP chart, this is actually an RNP authorization required approach.
You can only fly the RNP authorization required if your operator and you have been specifically authorized. To do that, both the operator and the pilot has to receive the required training. But why it is so particular, the RNP AR? The RNP AR is really particular because it's a 4D approach. 4D means that there is a control of the lateral, of course latitude and longitude, and that's the first two dimensions. The vertical, this makes the third dimension, but this will be a 3D approach like LNAV, VNAV, and LPV approach. In fact, the RNP AR is an RNAV VNAV, but it's an RNAV VR with the control of the speed, so it's a 4D approach. The pilot has to make sure that they are compliant with the speed as calculated by the FMS during the approach in order to be compliant with the approach. The reason is the RNP AR does not have the requirement to have at least 4 nautical mile final of flight to the runway. So you could have a turning route until the very last moment, until the touchdown point. And for this reason, the pilot has to make sure that he complies with the speeds for which those turns are calculated. Otherwise, the aircraft might overshoot the turn, and this overshoot could cause a flight technical error.
Paolo's Pilot Lounge. Like and subscribe now.
Well, with this we discussed everything about the approaches. There's one thing we still have to talk about, and it's what about the MIS approach? Is it still RNP? Can I fly the MIS approach with the RNAV? What should I do if I lose my RNP capability? Some of these questions have already been discussed. As I said, the PBN manual determines that it's the captain that has to decide the course of action to be followed shall the aircraft lose the RNP capability during the flight. So, of course, the best solution is to have a VOR and follow the VOR, but because the RNP approaches have been used to dismiss the VOR, this becomes more and more difficult for the captain to determine a proper course of action to be followed shall the aircraft discover to be RNP. Also, you have to consider that when the aircraft determines that it is unable for the required navigation performance, it is not said that the last given position was the correct one. So basically you find yourself in a situation where you don't know if the last given position is correct. Very often radar vectoring is a very good solution to the loss of RNP capability. The EASA certification specification for the airborne communication, navigation and surveillance actually clarify that the MIS approach has to be RNP. So the autopilot has to be able to follow the lateral navigation produced by the area navigation system during the MIS approach. What is interesting again is that the EASA itself states among the reasons valid for a MIS approach the fact that the aircraft lose the RNP capability. And of course, the MIS approach in RNP cannot be executed. So once again, we come back to the criteria we just said before. The captain has to establish a course of action. The PBN manual of the ICAO is a bit more clear and a bit more specific for the RNP approaches. So clearly, it's not strictly prohibited to make an RNP approach which has, for example, an RNAV MIS approach. But it's just that the ICAO manual does not take into consideration this opportunity, and even the EASA does not take into consideration this opportunity. So honestly, I don't know if it would be an acceptable mean of compliance for a local authority to make a MIS approach in RNAV. The PBN manual clearly say that the ILS procedure might culminate into an RNAV MIS approach, while the RNP approaches are normally RNP MIS approach, but they could be based on conventional navigation. So the option of going around using RNAV is not really an option for the RNP approaches. But we will see that the charts published are not always that clear about it. The fact is that part of the MIS approach could be still published as an RNAV procedure. To recap the MIS approach, we can say that an RNP approach will have an RNP MIS approach unless specifically specified on the chart. Some portions of the MIS approach might be RNAV, therefore enabling the aircraft to fly that part of the procedure as an RNAV procedure and not as an RNP in case the aircraft has lost the RNP capability but is still RNAV able. The ILSs might have conventional MIS approach or might have RNAV MIS approach, while the RNP could also have a conventional navigation-based MIS approach. In that case, of course, you will not need any RNAV or RNP navigation system serviceable to perform the MIS approach. It is also worth noticing that the EASA define a separate criteria for the RNP position certification certainty for the RNP AR authorization required MIS approach. So there is a specific certification for the RNP AR MIS approach which is more stringent than the normal RNP MIS approach. Well, with this we close the today discussion about the certification of the RNP procedures. I would say that today we completed what we started last time. So we discussed what are the RNAV, what are the RNP. We have seen the certification criteria, the augmentation systems available. We have seen how the errors are defined and what is the effect of the different errors. So the total system error, which as a matter of fact is the sum of the flight technical error that you always see, the path definition error, very important, that you always see, but only at the stage of debriefing. So it's very important that you verify on your navigation system that track and miles are consistent. And then the navigation system error that unfortunately is never visible to the pilot, unless you have a message saying enable required navigation performance. Apart from that, we discuss the change in name charts, we discuss the MIS approach procedures for the RNP procedures. In the next video, we're gonna take some example of RNP approaches just to put in practice what we have discussed here. Last but not least, I totally agree with those colleagues that say that I'm doing the things much more complex than what they actually are. I totally agree. The RNP is extremely simple in use, just load the procedure, press the LNAV. But as I said before, I think it's particularly important that the pilot understand what is he doing when he press LNAV, what kind of procedure is he flying, and what are the certification and the legal requirements behind. So I hope to see you at the next video, and for the moment the FMS is loaded, so I'll press LNAV.
Paolo's Pilot Lounge, like and subscribe now.